Welcome back, everybody. Mr. Wakefield here, looking at section 8.3 now. We're going to be looking at graphing again, graphing not on a number line, but on an actual bigger graph where you got, the x-axis and the y-axis here. We saw that earlier in the semester in Chapter 2. We talked about graphing lines. All right. And also in Chapter 4, we had those problems where we had lines and then the big shadings and everything. All right. But we haven't seen how to graph an actual shape that's not a line. This is the first time, first of many times here between now and the end of the semester, where we'll be graphing something that's not a line. It'll be a different shape. All right. Today, that shape is going to be either, let me show you another one of my sheets here. It's the same sheet. It just has some more details on it. These are the two different shapes we're going to do. All right. It's either going to look like this, where you have this thing called a parabola. Looks like a bowl shape. Okay. And it goes upward like this. You see there's a dotted line here. You don't have to put that dotted line there, but if you do put that line there, it has to be dotted. Okay. Because it's not a part of the graph. All right, it just helps you graph it. And the reason why it helps you graph it is because both sides of the dotted line are supposed to look the same. All right, you're not supposed to have one side that's like a really skinny looking thing, okay, that goes like this, and then the other side's really wide like that. It has to look the same. Same width on both sides. All right. Sometimes this parabola shape, as we call it, sometimes it is still the same shape, but sometimes it goes downward. All right, again, it still looks the same on both sides of that dotted line I put there. I'll explain how I find that dotted line, just like I'll explain how to find the actual parabola shape itself. All right. Why is it that it's not a line anymore like it was before when we graphed stuff? It's because... and let me jump over here. It's a little bit less messy. Same sheet again. When you get an equation and that they ask you to graph that's in one of these two forms, it is going to be one of those two shapes I just showed you there. All right, one of those two parabola shapes, sometimes up, sometimes down. Okay, the parabola will open upward if the A number is positive. Okay, the A number we're talking about right here. We'll get into what that is coming up here, but that's where it's located. It'll be in front of that bracket. Or if there is no brackets, then it'll be the coefficient of the x squared term here in this example. If that's positive, it'll be one of those parabolas that goes up. Okay, like you see here in this picture I just showed you. It'll be this one if A is positive, and it'll be this one if A is negative. It'll go down. All right. Few other things here. First of all, the f of x is the same thing as y. So if you get y in your problem, that's also qualifies here. For example, actually, I'll show you that example later coming up here. But remember, f of x and y are the same thing. So this could be a y right here on the left side of the equal sign. Okay, but what's the difference between this and lines? The big difference is that you have a variable being squared here, or a bracket that has a variable inside of it being squared. No, we're not doing the square root property here. I know it sounds kind of like that. Although that might come into play in some parts of the problem, but that's not our goal here. Our goal is to graph this thing. And the other thing is that that makes it different from that is that, remember, there's two variables here. Remember, this is a y right here. The f of x is y. So we have a two-variable equation here. We don't usually solve a two-variable equation when we get a variable by itself, although that, again, might be a part of it, but it's not the whole goal, all right? The goal usually when you have a two-variable equation, not always, but usually, as we've seen in the past with lines, is that we graph it, all right? That's one of the big things you do with the two-variable equations. And by the way, the A, the H, and the K, those are not variables. Those are constants. We just put those letters there because the constants will be different depending on what problem you do. All right, but there will be constants there. The only variables are the X and then the Y here, same as the f of X here on the other side of the equal sign. Those are the only two variables that you have. So when it looks like one of these two things, all right, where the A, H, and K are constant, or down here the A, B, and C are constant coefficients, All right, just normal coefficients you'd have in front of the x squared and the x, and then over here as well. When it looks like that, again, it has the x squared in it, unlike a line does, and so that's why these are not lines. But when it does look like this, they are parabolas. All right, not lines, but parabolas. And again, that x squared is the big clue. The x squared here and the brackets with the x inside of it being squared, that's something you don't see in an equation that we get a line when we graph it. All right, we don't see that kind of equation when we graph lines. So anyway, there's an introduction to that. Let's go ahead and jump into the first problem here, and let's see what we can do with that. Please notice in the first problem here that it is in this form right here, okay, because we know that when you have a on one side of an equal sign, if the whole thing here starts with just a bracket, that means that there's an invisible 1 being multiplied by it. You don't have to write that there, but I'm just emphasizing the fact that there's an invisible 1 right there. We can make it visible if we want to, but there is an invisible 1 being multiplied by the bracket there. And so the A is the 1. Okay, the H and the K, the H and the, oh, sorry. H is not equal to K, my fault. Okay. H is equal to, let's talk about that for a moment. The H is equal to not -1, it's equal to 1. Whenever you have the minus there, and we kind of saw this when we did some formulas earlier in the semester, when you've got the minus there, and you're trying to figure out what this is equal to, what the H is equal to, you got to change the sign because that's a minus. All right, so since that's -1, the H is actually going to be equal to +1. But since the K has a plus in front of it, that means you don't change the sign. Okay, so because the H has a minus in front of it, you change the sign to figure out the H. Because the K has a plus in front of it, you do not change that one. And so the K will stay as -2. You don't change that to +2. Okay. So with now that we've got the A, H, and K numbers, what is the purpose of them? The H and the K come together, and the H has to be the first one here. It has to be the X. All right, so the H and the K go together, and that forms what we call the vertex. The vertex is probably the most important part of our parabola. The vertex is equal to 1, -2. That is the point on the graph for the vertex. All right, the vertex is this number right here, or it is this point right here that I put in red. You don't have to put it in red, but I'm just emphasizing it. It's either the bottom of the parabola if it goes up, or it's the top of the parabola if it goes down. And it's also where that dotted line, if you choose to graph that it goes through that, straight up and down through that, so that you can then use that dotted line as a guideline, if you choose to do so, in order to make both sides of your bowl shape parabola, okay, to make both sides look the same, okay, same width, like we talked about. All right, but we can't just stop right there. We can't just graph the vertex and then draw the shape. All right, we're not sure yet if the parabola is really wide parabola or if it's a really narrow parabola. All right, it could be like really narrow like this right here, okay, or it could be really wide like this right here. We don't know that yet, so don't graph it yet. We're just getting started here. Now, what does the A number tell us? The A number tells us, because it's positive, that tells us that the graph is going to go up. All right, not down. All right, so that's a good thing to know here moving forward. All right, and so what do we need to do now? According to the directions, it says don't just find the vertex, but also find the intercepts. Just a reminder from earlier in the semester, the intercepts are the X-Intercepts and the Y-Intercepts. And you may remember when we did those, all right, back in Chapter 2, in order to find the X-Intercept, you plug in Y = 0. Okay, see how it says right here, intercepts, you plug in X = 0 for the Y-Intercept, plug in Y = 0 for the X-Intercept. Okay, this is from section 2.4, all right, if you'd like to look back at that. But that's what you do, all right? It's going to be a little bit more involved this time because the equation's got a square in it and all that. That changes the dynamic a little bit. But for X-Intercepts, we plug in Y = 0. Let's see what happens. Now remember, this entire thing right here, f of x is y. So that entire thing becomes 0, not just the x part. Okay, but the whole thing becomes 0. So we write this right here. 0 equal to x minus 1 squared minus 2. All right, so how do we solve that? The way you solve that when you have a bracket squared, all right, in one of these problems here is the square root property will always work. It doesn't mean the square root property always works in any problem this semester when you have a bracket squared, but it will work in this one, all right? So you can go ahead and do that. And as we talked about in the last couple of sections before this section, when you have a bracket squared and you want to do the square root property, what you do is you pretend like that's a variable right there that I boxed in. Like if we had y minus 2 right here, how would I get the y by itself if it was y minus 2? I would add the 2 over to the other side, wouldn't I? Okay, so I'm going to do that. And then once you got the bracket squared by itself, like we learned in section 8.1 and we reviewed it in the last section as well, is we learned that we get rid of the exponent and we do the double square root. But what's different about this problem is we actually need to graph these answers here. I forgot my negative, hold on. We actually need to graph these answers here. So if you put this in your calc, adding the 1 over, but we're going to have to do something different with the radical that we normally do, all right? What we end up getting is 1 plus radical 2 and 1 minus radical 2, just like always, all right? And so here's the problem, though. I need to graph those because those are my x-intercepts. How do I graph it when I don't know what square root of 2 is? Well, my calculator knows what square root of 2 is, all right? And I know some of you have what we call a 2-line calculator. That's this one over here. And some of you have a more old-fashioned 1-line model, which is fine, okay? Like I told you at the beginning of the semester, these are both fine, all right? Because these are both amongst the approved calculators that we have for the class. Let me just get set up here, get this thing turned on. If you're trying to figure out the square root of something, on this calculator here, what you do is you enter the radical button first. Let me find that. Here it is right here. And so it's above the button, so I need to activate it by hitting the second key there. But I see how I've got the radical on the screen there. I then put the 2, and since they opened up a bracket, they always do that on this calculator. Close it up. All brackets that are open must be closed. And then it gives you the answer right there. I'll talk about what that means here in just a moment. But let me just help those of you that have the 1-line calculators. In that case, you do the opposite thing. You enter the 2 first. Okay, if you want to know what the square root of 2 is. So you enter the 2 first. All right, and then you hit the square root of x button, and it'll tell you the square root of 2. All right, and there it is. Okay, here's the problem. This is when your decimal answer covers the entire calculator screen like this does. That's not exact, and I always tell you guys, don't give a answer that is not exact. All right, this is not exact. They actually rounded it off at the end. This thing actually goes on forever. Okay, it would keep on going. So if your decimal covers your entire screen, that means it's not exact. So normally, unless I tell you to round it up, normally you're not supposed to use this, but the one exception to that is when you're trying to graph like an X or an Y on an XY graph like we are right now. So in that case, because we have no choice, we have to graph it. So what you can do, what you are allowed to do in this case, when you get one of these decimals that covers your whole screen, I'm okay with you just rounding it off to the nearest 10th place here, right here, which is the first decimal place after the decimal point. So if we do that, that would be 1.4, wouldn't it? 1.4. So what I'm going to do right now, since I have to graph this, is I'm going to say 1 plus 1.4, and then this is 1 minus 1.4. What are those two things equal to here? Those two things are equal to, this one is 2.4, all right, and then this one is negative 0.4. All right, again, we wouldn't normally do this. Normally, we would just keep the radical as part of the answer like we did in the last couple of sections because we want an exact answer. But here we have no choice. We have to graph it. So I am going to actually approximate the radical in that case when that happens. All right, if it ends up being a decimal that covers your whole screen, which a lot of radicals are, unless they're perfect squares underneath the radical. A lot of the radicals will be like that. You're allowed to do that when you're trying to graph something on an XY graph. Don't do it in other situations normally, but when you're trying to graph something on an XY graph, that's when we do that. So, so now we know what our X-intercepts are. Almost done here. All right. I don't want to graph anything yet because I'm not sure if I need to change the scale of the graph. All right. I'll get into that here in just a moment of what that means, but that will be important though. The Y-intercept is a little bit easier to find. The Y-intercept, you plug in x equal to 0 here. All right. Remember, f of x is the same thing as y. So I'm going to write down y equal to and then I plug in the 0 right here. So the 0 is going to be, gives me what? 0 minus 1 bracket squared minus 2. Since the y is already by itself, all you got to do is just do order of operations on the other side here, since there's no variable over there, and it'll tell you what y is equal to. All right. Parentheses first, then your exponent. Okay. And then finally, the subtraction. All right, so now finally, after all that, we've got everything that we need. Okay, and since our numbers are pretty small, sometimes when they're bigger, I need to change the scale, as I'll talk about here when we get to a problem like that eventually. But since the numbers are pretty small, I've got some 1s and 2s and some decimals that are pretty small as well. I'm just going to go ahead and do a normal scale here. Make sure that when you do this here, as I mentioned before, all of your marks have to be equally spaced out. Okay, so 1, 2, 3, 4. You can't do like 1, 5, 6, 8, something like that. It's got to be all equally spaced out. So even if you change the scale, it's got to be like that. And again, I'll get into that here eventually. Let's graph the vertex first. 1 comma negative 2 is right here, isn't it? Right here. Okay. What about the X-intercepts? Well, since they're decimals, here's what you can do. This is okay to do this. If you get a decimal, just figure out what 2 marks that it's between. For example, 2.4, because it's 2 point something, that means that it's between 2 and 3, isn't it? Okay. And so you just go between 2 and 3, and since it's an X-intercept, we put it right on the X-axis, like any X-intercept would be. All right. And then negative 0.4, because of the fact that that is negative 0 point something, that means that it's between 0 and negative 1. And so just put it in between that, all right? That's all you got to do. You don't need to be any more exact than that because it's such a small space in between those 2 marks anyway. Just put it in between that and I'll be fine with that. And then also we need to do the Y-intercept, which is negative 1. That would be right here. And so you can see here with these 4 points that a bowl shape, parabola type shape is starting to develop here. And it goes up just like this up here told us that it would. All right, so you can draw that dotted line if you wanted to. It has to go straight up and down through the vertex. All right, you don't have to. But it might just help because it's got to look, the parabola's got to look the same width on both sides of it. So let's go ahead and draw this thing now. Before I draw out a couple of the key points, it's got to be a smooth looking shape, you guys. All right, it cannot be, for example, a sharp turn here like a V shape would be. It has to be a smooth looking shape here, nice smooth turn, all right, not a sudden sharp turn like a V shape would be. The other thing is that, as you can see here on our parabola shapes, is that they have arrows on both ends, don't they? Okay, whether it's up or a down parabola, it doesn't matter. Arrows on both ends. And so let's do those 2 things. Make it a smooth turn here, like that. Okay, make it look the same on both sides, same width, all right. And then put arrows on both ends. And we did it. All right, that's what we need to do. So you need the vertex, you need your intercepts, and then you just need to draw the shape using the guidelines we just talked about. Smooth turn, okay, arrows on both ends, all right, and make sure both sides look the same width. All right, let's try that again now. In problem B here, that looks a little bit weird because the bracket is behind the 1 right there, but I want to make sure you understand that this is the same thing as this right here. Let me write it down. Okay. When you have a positive 1 minus a bracket squared, it's kind of similar to when you have, you don't have to write this down, but it's similar to when you have a positive 1 minus a variable squared. Positive 1 minus a bracket squared, positive 1 minus a variable squared. Very similar thing, where if I reversed around these two terms, wouldn't it be equal to this right here? Wouldn't that be what it was? Okay, negative m squared plus 1. So in the same way, it would be negative bracket squared plus 1. All right. With the negative still being outside the bracket, just like it was here. All right. Now, as you can see, it now looks like this, where the A is what? The A is negative 1. And what is the H and the K numbers? I keep on doing that. Sorry. H, I want to say H equal to K. I don't know why. But the H is what? The H is, as we said, you have to change the sign to figure out the H. But the K, you don't change the sign. So that stays as positive 1, but the negative 3 changes to 3. So you change the sign inside the bracket to figure out the H. You don't change the sign of what's behind the bracket to figure out the K. All right? Now, this means what? This means that the vertex is combining those two numbers together. The H number always comes first. 3, 1. 3, 1. What does the A mean? Well, since it's negative, that means that the parabola this time is going to go downward. Okay? It's going to look like that, basically. It might be a little wider or narrower than that. We don't know yet, but it's going to go down. That's why I drew this. It's just to tell you that it goes down. So, now that I have my vertex, what are the other things I need? I need my my X-intercept and my Y-intercept. X-intercepts, how do we find those again? We plug in y equal to 0. Y equal to 0. Okay, so that means that f of x becomes 0 right there. All right, because that's the same thing as y. You could plug it into either one of these two things here. They're the same thing. I just reversed this around here when I wrote that down to make it easier to see that it is really the same thing as this. Okay, that's why I did that. But you could plug in, when you do the X-intercepts, you could plug it into either one, whichever is easier. But once again, when you have a bracket squared in one of these parabola problems, all right, you want to do the square root property, and you will be able to. So if this was 1 minus y, what would I do to get y by itself? If it was 1 minus y, it would be, I would move over the 1 over to the other side. I would then divide out by the negative 1 right there. Just like if it had been a negative y, you divide by negative 1. Same thing here. Okay, the negatives cancel, just like they would if you were dividing negative y by negative 1. Same thing. All right, what do we get here? We get 1 is equal to x minus 3 bracket squared. Now that you've got the bracket squared by itself, with no variable on the other side, you can now do the double square root thing that we've done so many times here in the last few sections. And this time, unlike the last problem, the square root that you get is a perfect square. All right, it is a perfect square root, and so you don't have to use your calculator and get some weird decimal answer this time. Okay, but as I've told you before, though, when you get the double square root and it ends up being one of those perfect squares underneath, figure that out right now so that it's easier to move the 3 over after that. So the square root of 1, as you know, is 1. All right. And so then when I move the negative 3, and this is negative 1 then as a result. But now that I move the 3 over, what's going to happen? If I add the 3 over to the other side, I'm going to get x equal to 1 plus 3 equal to 4, and x is equal to negative 1 plus 3 equal to 2. And so those are your X-intercepts. Okay, let's do the Y-intercept. Again, do everything first before you start putting anything on your graph, because if the numbers get really big, we might have to change the scale like I've been talking about. We plug in x equal to 0 here. All right, so I'm going to get what here? Again, the f of x and the y are the same thing, so I'm just going to write down y right here. And then we have what? We have 1 minus 0 minus 3 bracket squared. Okay, do order of operations here because there's no variable on this side. So figure out what that side of the equal sign is equal to. Parentheses tell me -3. Then -3 squared is 9. Then we subtract and we get y equal to -8. Okay. All right. Now, -8 is kind of a big number. All right. You'd have to put a lot of marks on here in order to fit all that on. You could do that. But what you could do as an alternate option, if you want, and you don't have to do the same thing on both the x-axis and the y-axis, but since the y is kind of a big negative number, what you can do is go like this. You can go, instead of doing -1, -2, -3, -4 like you usually do, you would do -2, -4, -6, -8. But remember, if you're going to do that, two things. Number one, they've got to be the same distance apart. You can't do -2, -3, -4. All right. See how each one of these marks is a distance of 2 apart from each other. Okay, it's a distance of 2 to go from -2 to -4, from -4 to -6, and so on. The other rule is that once you do that for part of your axis, in this case the y-axis, you've got to do it for the entire axis. All right, all the way up here to the top as well, from one end of the axis to the other. And that goes for the x-axis as well if you were to do it for that. And so it's got to be the same distance. Every mark has to be the same distance apart from one end of the axis to the other. You also, if you're going to change your axis numbers from the normal 1, 2, 3, 4 that we normally do, you don't need to write down all 8 of these numbers. Just write down a couple of numbers so that I know how you changed it. You don't have to give any more detail than that. Just write down a couple numbers so I know what kind of scaling that you're doing. Your scaling here is by 2s. All right, and so writing down a couple numbers is enough. Speaking of the x-axis, you do not, at least not with parabolas. Later on, we'll see some problems where you have to do something different. But the x-axis and the y-axis, you guys do not have to be the same scale. So if you're doing the y-axis by 2s, you can still keep the x-axis the same if you want. Although you're certainly welcome to change that to being 2, 4, 6, 8 as well if you really want to, but you don't have to. It doesn't have to be the same on both the x and the y. So with that in mind, where is 3, 1 located? 3, 1, remember the 1 is halfway between the 0 and the 2, so be careful there. All right, it's halfway between the 0 and the 2, so that's what I did right there. But then this mark right here is 3 right here. And so I put that dot halfway between 0 and 2 on the y-axis and at 3 on the x-axis. What about these X-intercept and Y-intercept points? The X-intercept is right there and right there. And the Y-intercept is right here, according to the numbers that I got up here. Okay? So those are the 4 points that I have right here. Okay? And you can see that a upside-down bowl shape is starting to develop here. Once again, an optional thing that you could do is to put this dotted line right here. It just helps you make sure that both sides of the dotted line are the same width. But some people are comfortable making sure that it's the same width without even drawing the dotted line. They can just visualize it. That's fine. The dotted line is optional. Now, what is the rule when we draw a parabola? Okay. Smooth turns, okay, make sure this is a smooth turn here, not a sharp turn, like a V shape would be. All right, make sure that it's the same, the parabola looks the same on both sides, same width on both sides. All right, you don't have one side that's really way out here wide, and the other side is really narrow like that, okay. Make sure it's the same. And that's especially important over here because there's no points over here, okay, so make sure you don't like go way out here or something. It won't look the same on both sides anymore. All right, and of course make sure you've got arrows on both ends. Okay, let's move on to the next one here, problem C. This one looks a little bit different because and it's going to have some different things going on with it within the problem as well. But first of all, the y is not by itself, is it? These two formulas that we have at the top of the page, the y is by itself, isn't it? Okay. And so how do we get that? When we have y minus a term and we want to get y by itself, what do? We add the 3 over to the other side. Okay. We just add 3 to both sides. The 3's would cancel here when you do that, and then the 3 ends up over there. So now, doesn't it now look a lot like, in fact, it actually looks a lot like the first problem, doesn't it? Okay. Looks a lot like this first problem here. All right. But what's important is that it looks like this. That's the most important thing. So, because it looks like that formula at the very top of the page, we know it's a parabola. We know that since it is a parabola, we need to do our A, our H, and our K numbers. Okay. And what are they? Well, since you don't have anything in front of the bracket there, that means that A is 1 again. Remember, to figure out the H, you got to change the sign inside the bracket, so that's going to be positive 1. And then for the K, you don't change the sign, so that stays as positive 3. All right. So what is the vertex? H always comes first. The vertex is 1, 3, isn't it? 1, 3. All right, now, what else do we got to do? We got to find the X-intercept and the Y-intercept. The A, though, is what? Since it's positive, that means the parabola is going to go up. All right, I've got some good news, though, for you right now. All right, this did not happen in the first two problems, which is why I didn't mention it until now. But the vertex is somewhere, don't graph it yet because we don't know how we want to change our scale potentially. But isn't the vertex somewhere around here? But it's above the x-axis, isn't it? Because the y is positive. So it's somewhere up in this area. All right. Okay, now, notice that it says that the parabola is going up. Isn't it now, here's the thing. If you got a vertex in this area here above the x-axis, I'm going to erase this, all right, because I'm not ready to graph it yet, but just to demonstrate, okay, if the vertex is there and the parabola goes up, doesn't that mean that it's impossible for it to hit the x-axis? Okay, the parabolas don't turn around once they go in one direction, all right? They're not going to loop back around and come down. So if your vertex is already on one side of the x-axis, you guys, and the parabola is supposed to go away from the x-axis, which this tells us that it does, okay, because it's already above, the vertex is already above the x-axis, and this says it's going up, so it's going to be going away. Doesn't that tell you that there's no x-intercepts? And isn't that nice to know that in advance so I don't have to do all that work trying to find them? Okay. So let's write this down. No x-intercepts. Again, why is that true? The reason why it's true is because we know that the vertex is above the x-axis and we know that it's going upward. This is not the final graph. It's just kind of a rough sketch of it. But it proves that it's not going to hit the x-axis. And that's what x-intercepts are. They're supposed to hit the x-axis. That's the whole purpose of them. All right? Now, let's say, for example, you're doing your homework or you're doing a test question and you forget to check this thing. You forget to check to see if the parabola is going away from the x-axis as opposed to going towards it. And so let's say that you do the normal thing and you plug in y equal to 0 and you figure out the whole thing. That's okay too. Okay, it's just that you could do that. It's going to take you more time. But what's going to happen? Let me make sure you're aware of this. What's going to happen every single time when you try to find an x-intercept that isn't really exist, like in this problem, when you try to find an x-intercept that doesn't exist, you are always going to get the square root of a negative number. You would get the square root of a negative number here instead of, for example, positive 2. Okay? Or positive 1 like we had here. Now, in the last few sections, we talked about, oh, square root of negative numbers are okay, right? But not in this section, all right? Whenever you graph something on an XY, x-axis, y-axis grid, there's no imaginary numbers on here. And x-intercepts are supposed to go on your graph. So if you forget to check this and you try to find the x-intercepts and you end up getting the square root of a negative number, which you will, that should be a clue to you that, oh, yeah, this is one of those problems where there are no X-intercepts. Because you can't have an imaginary number on a graph, and the square root of a negative number is just that. It's an imaginary number. So this is easier to check this in advance, okay? But you could also discover that there's no X-intercepts by actually doing the work as well. All right. So in these last two problems, if you had checked it, you would have realized that, oh, hey, the vertex, because the y is negative, it's below the x-axis, but it goes upwards. So if it's below the x-axis, but then the parabola goes upward, that means it's going not away from the x-axis, but towards it. That's the reason why I found the X-intercepts, is because I knew that it was going to go towards the x-axis instead of away from it. But here, all right, was different, as we just found out. So that's it. That's probably the hardest work that you have to do in one of these problems, isn't it? Okay, to find the X-intercepts. So it's nice when you got a problem where there aren't any. All right, so it's a good idea to check that first. Y-intercepts are easier because the y is already by itself, all right? You just got to plug in the x equal to 0 right here. And what is this going to be equal to for the y? Parentheses. Exponent. And we end up with y equal to 4, don't we? Like that. Okay, so we only have 2 points to the graph this time. We have the vertex and we have the y-intercept. The 2 additional points that you normally get for the x-intercepts obviously don't exist. It may seem like that's not a whole lot of information, but as I'll show you here, it will be. Okay, here's the vertex right here. We don't need to change the scale this time because the numbers are pretty small. 1, 3, 4 is what we're graphing here, those numbers. So nothing big there. But here's the 2 points. There's the y-intercept right there, right on the y-axis at 4, and then there's your vertex. Okay, now, the dotted line really helps here. Okay, whether you graph it or if you just visualize it in your mind, it really helps here because there's no points on this side of the parabola. But we can draw a bowl shape over here. Half of a bowl shape, of course, all right, since it's just on one side of the dotted line. And then just so long, even though you don't have any points over here, you guys, as long as you make the other side look the same width, all right, you don't need any points over there. Watch what I do here. I'm just going to make it look the same as the left-hand side, like that. Okay, so as long as it looks the same, all right, then you don't need any points over there, all right. And so sometimes when you don't get the X-intercepts, it's not the end of the world. Just keep that in mind, okay? Just make both sides look the same, and that'll help you graph it. Okay, moving over here to problem D. Obviously, this is doesn't have the bracket squared in it, but it does fit into this right here where you got the x squared term, the x term, and the constant term. You can have minuses in between. They don't have to be pluses. All right, minuses are okay. Just like right here, this could be a minus instead of a plus. And even this right here on the inside could be a plus instead of a minus. Those are all okay. The pluses and minuses are interchangeable. So with that in mind, how do we use this? It's going to be a different strategy, but it's still going to be the same result. It's still going to be a parabola. All right, this right here is your h right here, negative b over 2a. I want you to notice something here. The negative b over 2a, that's the same exact formula as the quadratic formula that we just did in the last section. The only difference is that it doesn't have the radical, the big radical that's in that formula. It doesn't have that, but other than that, it's the same thing. So it's just kind of an easier way to remember it is to think of it as the quadratic formula without the radical, and also without that plus or minus in front of the radical as well. All right, so that's what that is. And then the k part is telling you when you figure out what this fraction is equal to plug it into the f. All right, or in other words, plug it into since it's supposed to be the x number, since it's the first, since it's the h right here, it's supposed to be the x number. You plug it into the x part of the f, and then that'll tell you what the y part is. I'll get to that, don't worry. Let's figure out what this fraction is equal to first, though. And so In order to do that, we need to figure out what the A, B, and C numbers are. It's going to kind of sound like the quadratic formula, but we're not doing that here. All right. So we got what here? We got the A is 1, the B is -2, and the C is -15. The C actually is not overly important for the vertex part. It'll be important later. But what does this mean for the vertex? It means that the -b/2a, how did we figure that out in the quadratic formula? We figured out that the -b/2a, and you can put the negative inside of the top here. You don't have to put it in front like I said on the top of the paper there. It's the same either way. But what did we do when we had -b/2a without the radical? In the ignoring the radical, obviously here in the quadratic formula, what did we do when we just did the -b part of the quadratic formula and the 2a part? We just plugged the numbers in, but when we did the b part, didn't we just change the sign of it? Remember that in the last section? All right, you just change the sign to figure out -b, and so that gives you 2. And then on the bottom, we did 2 times 1, didn't we? What is this fraction equal to? Figure out what the top and bottom are equal to first. There's no variables getting in your way, so do that. And then that's 1. Now that's the H. That's the H part of the vertex. All right, this is the H right here. So then what is the K part? The K part is figured out by plugging in the 1 into X right here. So let's do that. What is f of 1 equal to? It is equal to 1 squared minus 2 times 1 minus 15. All right. And let's just figure it out the way we normally do when we plug stuff into functions. All right. Into f. Exponent first here. And then we do what? We do -2 times 1 is -2. And then finally we subtract. Got to go from left to right though. So -1 when you subtract these two, and then -15 would be -16. So what is the final vertex now that I've figured that out? The final vertex then is going to be the H number always comes first. That's the 1. And then the K number is what you get when you plug the 1 into the F. Okay, so that would be -16. So that's how you figure out the vertex when it's written like this. Okay, the second type of the second formula we have at the top of the page. All right. So now, the vertex, as you know, because the y is negative, it's going to be way, way, way down here somewhere. The A number is telling us what? The A number is telling us that the parabola goes upward, isn't it? Like this. So doesn't that mean that unfortunately, doesn't that mean that it's going to go, the parabola is going to go towards the x-axis instead of away from it? Because it starts out below the x-axis because the y is negative, but then it's going to go up towards it, isn't it? So unfortunately, we are going to have to find the x-intercepts. All right, so we got to do a little extra work compared to the last problem, but we'll get through it here. So the f of x changes to 0 when you do the x-intercept. Okay, like we talked about before. And doesn't that look like notice when you plug a number into one of the two variables, all right, in this case 0 into y, you have only one variable left. So you're trying to solve a one variable equation. Doesn't this look like a normal quadratic equation here? Okay, with we have 0 on one side, and this looks like something that we could factor. So we could do the factoring method, all right. In particular, we can do the Bary method here, all right. Hopefully it'll factor. It actually does, though. Don't worry. And so we get what here? We get, it's actually going to be, if you do the Bary method, it's going to be x minus 5 and x plus 3. Okay, because -5 and 3 are the two numbers at work right there. We set those equal to 0. The last step of the Bary method didn't give you anything there. All right. Didn't have to factor in that the GCFs were 1 inside of both of those brackets. What are the two numbers I get here when I solve those resulting equations? Again, doing the factoring method here for quadratic equations. 5 and -3. So that wasn't too bad, but The last problem was still nicer in that you didn't even have to find the X-intercepts. What's the Y-intercept? Y-intercept means that we plug in what? We plug in 0 into F, okay? Because, again, you want to plug 0 into X. And so that, in other words, it's F of 0. You could also just say that this is Y right here, all right? But the point is that either way, whether you put F of 0 here or you put Y here, it doesn't matter. What's important is that you plug in 0 into the other side of the equation here, all right, from where the F of X is located. Okay. Exponents. Multiplication. Okay. Okay. And so that's just going to end up being negative 15, right? And so we have everything we need now. We have a vertex. We've got the intercepts. All right, we're ready to go. But some of the numbers are kind of big, aren't they? Big in the negative direction, but they're big. So what I would recommend, okay, you can do it however you want, and you can extend this down a little bit here as well. There we go. But I'm going to do this by threes. I'm going to say negative 3, negative 6. Again, you don't have to say anything more than that, all right? You don't have to put all the numbers there. Just do a couple numbers so that I know how you're changing your scale from the normal 1, 2, 3 scale. Remember that the top of the y-axis has to be the same, all right, if you graph anything up there. But where would be the negative 15 and the negative 16? And by the way, I'm going to do the x-axis in the normal way, 1, 2, 3, 4. So 1 comma negative 16 will be right about here. And I know that because negative 15 is right here, if you count by threes going down. Okay, so 1, negative 16 is the vertex right here. The y-intercept is right here. Okay, and then the x-intercepts are where? They are at x equal to 5 way over here. And then x equal to negative 3 is going to be right there. Okay, and so you can see a bowl shape once again is starting to develop here. Okay, now let's go ahead and start drawing that thing. Now that I have all my intercepts and my vertex on the graph, it's time to draw the shape. Arrows, smooth turns, and make sure it looks the same on both sides here. And I kind of got a little bit off there. Let me see. There we go. All right. And I did it. Okay. So there we go. So that is what happens when you have it written in this form right here without the bracket. Okay. That's how you do the parabola. All right, in that case. One more here, same idea. Again, no bracket. I know that the terms are out of order. If that's the case, please put them in order. Like this. Okay, so if you've got those three different terms, the x squared term, the x term, and the constant term, put it in the right order, okay? Partly just because you don't want to get thrown off by things being out of order, all right? What is, and again, the C number is not important on this particular step, but what is the A and B numbers here? The A is 2, and the B is negative 7. And so what would then be that negative B over 2A thing? What is that? Okay, that is going to be... let's write that down here. Negative B over 2A is going to be, again, the negative B changes the sign of whatever B is, just like in the quadratic formula and just like in the last problem we just did. So that's going to be positive 7 on top. Goes from negative 7 to 7. And then underneath that, we plug in the 2 for the A, and we get, isn't this going to end up being 7/4? Okay. It's a fraction. Okay, we'd rather not have a fraction, but that's the way it is, all right? You can make that into a decimal if you want, all right? Don't round it off, though, if it's not one of those decimals that covers your whole screen, all right? 7/4. If I put that in my calculator right now, that's going to be equal to 1.75. 1.75. So since it's a little decimal, go ahead and just keep that intact. It's always good. You always want to make things exact and not round off if you can, unless the directions say otherwise. So 1.75, if I plug that in, I'll put it up here. If I plug that into the function, that'll give me the other part of the vertex, just like in the last problem. All right. So 2, plug in the 1.75 wherever the x is located, like this. All right. There we go, right there. And what is all that going to be equal to? Well, certainly your calculator is going to be of assistance here, isn't it? Okay, because you got the decimals. So keep that calculator handy. If you've got, if you do your exponent there first, we get 3.0625. Multiplying that by 2, I get, let me go and write that down, 3.0625. And then if we then multiply, we get 6.125 minus 12.25, and then you subtract. Start out from the left, as always. When you subtract, if subtraction is all you got left, all right, go from left to right. So we get negative 6.125 on the first part, and then minus 4 is going to be negative 10.125. So your vertex is a little bit more complicated this time. All right, your vertex then is going to be what? Your vertex is going to be 1.75, comma, negative 10.125. All right. But we know how to graph decimals. All right. You don't worry about that. You just need to put it in between the two marks like we did in the decimals earlier in problem number 1. Now what are my, let's see what's going on here with my intercepts. The A number is positive, so that means that the graph's going to go up. Since the vertex has a negative y value, though, unfortunately, that means that the vertex is going to start out at the bottom of the graph, and it's going to go towards the x-axis and not away from it. So we do have some work to do here to figure that out. Fortunately, though, the Bary method will help us here, though. The Bary method, if we plug in 0 in the place of f of x, because f of x and y are the same, put the terms in this order that I changed it into. It does matter this time because, remember, when you're doing the Bary method, which we want to do, because you have 0 on one side and you've got these 3 different terms over here, that's telling you to do the Bary method. In that case, you want to make sure that they're in that order, and you want to make sure that the x squared is positive. If the x squared was not positive, then what you do is, and you'll see this coming up here, what you do is you move the 3 terms all over to the other side, and then the x squared will become positive, and you'll still have a 0 on the right-hand side now. So you can still do the Bary method if you do it that way. What is the Bary method here? For negative 8, 2 times negative 4 is negative 8, and we need negative 7. That's going to be negative 8 and 1. Negative 8 and 1. But we need to factor out the GCF out of the brackets in the Bary method, so that's why it's going to be x minus 4 right there. X minus 4. All right, this had a GCF of 1, so that bracket doesn't change. I set these equal to 0, and what 2 x-intercepts do I get on this one? I get x equal to 4 by adding the 4 over to the other side. Here I move over the 1 over to the other side, and then I divide out the 2. So my 2 x-intercepts are 4 and negative 1/2. Okay. By the way, where is negative 1/2 on a graph? Okay, if you put that in your calculator, and you probably already know this, 1 divided by 2 is 0.5. So negative 1 divided by 2 would be negative 0.5, And we now know how to find that on a graph. We talked about that, and I'll show you that here again anyway. So what's the y-intercept? The y-intercept is found by what? By taking the x and making it equal to 0 and plugging that in. Okay. If you've got one of these normal polynomials here where you no brackets or anything, but you got the x squared term and the x term and the constant term with pluses or minuses in between it, okay, whenever you plug a 0 into that, and this only works for 0, but if you plug a 0 into that, the answer will always be just the term that doesn't have the variable in it, because the variable terms will automatically just become zeros. Okay, so the answer is automatically -4. I could have done that on the last problem, but I kind of did it the long way there. But you could have, yeah, whenever you have just a normal polynomial, terms with pluses or minuses in between, normal terms, no brackets, okay, there, as you can see here, the terms that have the x's in it just become zeros when you plug in 0. And so the term that didn't have a variable in it is what you end up with every time. So it's just a little bit of a shortcut there for you. Okay. Now, we got kind of a big number here, -10, so I'm going to spread out my scale here. I'm going to do this. I'm going to do -2, -4, -6, like that. I'm going to go by 2s. Again, you just need to give me a couple of numbers there when you draw that out. All right, -2, -4, -6. You don't even need to draw that many numbers. Just a couple of them is fine. But what is a vertex? A vertex is 1.75, which is in between 1 and 2, and -10.125, which is just below the -10 on the y-axis. And so putting those together, it's about right here. Okay. About right there. And then we go ahead and graph my x-intercepts, excuse me. They are +4, which is right here. -1/2, which is -0.5. That's halfway between 0 and -1, right there. Okay, and then my y-intercept was -4. It's right here. And so once again, you're seeing a parabola developing here. It's kind of a skinny one. Okay, it's not one of those wider parabolas that we've seen. But let's draw the shape. And now when it's a skinnier parabola, you got to be really careful to make this look like it's smooth. Okay? It's so easy to make it into a V shape if you're not careful when it's a skinnier parabola like this. So be careful there. See how I intentionally drew this here to make sure that it was a smooth turn here. Okay, it's kind of like when you're in a car and you have to make a sharp turn, all right? But your car cannot do a V shape. It can't just suddenly change directions like in a V shape. It's got to turn smoothly. And so it's just harder to do that. And it's the same thing when you're drawing. It's harder to draw that. But so just be careful. All right. Make sure it's smooth. All right. And so there you go. In these next 3 problems here, I'd like you to try those as usual since they're numbered. Couple notes here. First of all, remember that here there's a plus inside the bracket. So the H number is actually going to be -3 then. Remember, you're supposed to change the sign to figure out the H from the inside of the bracket. And then another thing I wanted to point out is, again, put these in their correct order here, just like we did in this problem here. And because the x squared is negative, when you do that step where you got to figure out the x-intercepts, move all of the terms over to the other side, and that'll make the x squared positive. All right, and of course I'll show you the answers to this here and as soon as you hit the play button again, so please try those and then hit the play button. Okay, guys, I'm just going to go ahead and put the answers up here, and instead of going through it step by step, but I will go through it step by step talking about it, though. So let's do that. How did I find the vertex here, 3, 2? I changed the sign of the inside, and I did not change the sign of the outside. That's what you do when you got the bracket squared, that form. All right, so we got that. I knew that the graph was going up because the A was positive. All right, and then there is no X-intercept because of the fact that it's one of those problems where the vertex is already above the x-axis. Since the y is positive, it will always be above when it's positive, and the thing is supposed to go up, and so it's actually going to be going, as you can see here in this picture, this rough sketch right here, it's actually going away from the x-axis, and so I knew that in advance, and so I declare that there's no X-intercepts. Again, if you found the X-intercepts, if you actually tried to find them, you did the work, you should have gotten the square root of a negative number, which then automatically clues you in on the idea that, hey, I can't have any imaginary numbers on my graph, and so there must be no X-intercepts. Okay? So no matter which way you do it, you can figure out that there's no X-intercepts. Y-intercept, this is how I figured it out right here, the same way I normally do. Okay, and then I plotted my points. I have only 2 points because there's no X-intercept, but because of the dotted line and because both sides are both supposed to look the same, I was able to graph this side over here even though there was no points to refer to, no plotted points to refer to, because it looks the same as this side. And then this point over here helped me draw the left-hand side, so that's why I knew that the left-hand side was, that it looked like this right here. And then you just make the right-hand side, like I said, look the same. Okay, so that's number one. Number two. Here we see that the vertex is -3. Again, you got to change the sign of the inside. Don't change the sign of the outside. So -3, -4. The vertex, pardon me, the A number tells us that it goes up. So yes, this time there will be X-intercepts because it starts out below the x-axis, but it goes upward, so it's going to be going towards the x-axis from the bottom end. So I went ahead and figured out my vertex here. Okay, or pardon me, not my vertex, my X-intercepts. And so how did we get that? Again, pretending like the bracket squared is a y right there. Like if we had 2y minus 4, then we get the bracket squared, the red box by itself, by adding the 4 over to the other side, dividing out the 2, all right, and we get this right here. Just like I did in the very first problem in this section, though, when you get a square root that's not one of those perfect square numbers, like square root of 1 or square root of 4, okay, go ahead and still get the x by itself, but then because we need to graph it, you're welcome to go ahead and put that into your calculator, figure out what it's equal to. In this case, it's 1.4, and then -3 plus 1.4 is -1.6. -3 minus 1.4 is -4.4, and that's how I got the X-intercepts. Y-intercept, once again, is figured out the same way as normal. You can see what I got there. And then that gives me this right here, this graph right here. Let me zoom in on it for you. I'll come back to the whole thing, though, in just a moment. So I plotted all the points I was supposed to plot here. All right, I did a scale of 2 on the y-axis, but I did not change the x-axis. Again, you can do it however you want. Just tell me what you're doing. Like I said, if you're changing it from the normal 1, 2, 3, 4 scale, tell me what you're doing. So I plotted the stuff. I did the normal thing for the parabola, and this is why I got what you see right there. Okay. So let me zoom back out here. All right. And so that is problem number 2 right there. All right. Problem number 3. Let me go ahead and zoom in there for you. Again, I changed the order there. I know that my B is -4, so the negative B changes it to +4, +4. I know that the A number is -1, so I plug that in down here. Figuring that out, 4 divided by -2 is equal to -2. That's your H number. If I then plug in the h number, remember that this is -1 in the front here because it says negative x squared. That means -1 times x squared. All right, a lot of people miss that. All right, do the exponent first. The exponent only applies to the bracket when the bracket's next to the exponent. So do that, you get the 4. That is -1 times 4. -1 times 4 right there, which is -4. I'm just emphasizing that. All right, I know I already had -4 written there, but I wanted to just emphasize that's how I got it. And then we get -4 plus 8 is 4. 4 plus 5 is 9. So your vertex is -2, 9. All right. Since the parabola goes down due to the fact that A is negative, it is going to go towards the x-axis because the vertex is above the x-axis. So yes, we got to figure it out. Okay. So like I told you just a few minutes ago, this looks like the Bary method, but we can't do the Bary method normally. At least there actually is a way to do that, but I didn't want to bog you down with more methods and stuff when we originally learned the Bary method. Okay, so please don't do that unless you're sure you know what you're doing. But normally we do the Bary method with just this being positive. Okay, so move all the terms over to the other side. You can see I did that here. Add and subtract them over. That then makes this side equal to 0, and now everything's over on the left side. So now the x squared is positive. Now I do the Bary method, and I get these two answers right here. There's my two numbers, 5 and -1 that I got for the Bary method. Then I figure out my X-intercept or my Y-intercept, as I told you guys before, as I promised you, when you got a normal polynomial. Okay, just terms with pluses or minuses in between them, no brackets or anything. All right, just your normal polynomial. The x terms, when you plug a 0 into them, they just become zeros. And so the 5 is the answer because that's the one term that didn't have a variable in it that would have made that term 0. Okay, so these terms become zeros, and so all you got left is just the 5. And that's why the y-intercept is 5. So my final graph is going to be what? Right here. Okay, let me zoom in on that for you. Okay, I put my y-intercept, my two x-intercepts, my vertex. All right. And I didn't put the dotted line on there, but again, that's optional. All right, what's important is that both sides of that dotted line, whether it's invisible or visible, looks the same width. Okay, so let me zoom back out for you. All right, so let me know if you have any questions about this section. A lot of stuff going on here, all right? But as always, the more you practice, the better you're going to get at it, okay? And so yeah, let me know if you have any questions about 8.3, and you have a good day.